I'm just cutting out a blank now for the temporary drive pulley for the wheel, so I can do some serious truing and crowning. Well, that's done. I haven't videoed the gruesome business of cutting MDF on a power tool. I didn't use the router because that's really messy on MDF. I used the table saw instead. First of all, I chopped it down to an octagon on the sled and then a hexadecagon. So the next thing is to create a V section in there, except as Matthias says, there's no need for it to be a V, a square section will do. So I'm going to pop a biscuit cutter into the router and cut the section into the edge of that wheel that way. The biscuit cutter cuts a 4mm groove, and the pulley, although the stockist didn't know, I can see is an A, which is a pretty standard small to medium sized pulley, which means the top dimension of the belt here should be 13mm and the depth of the belt should be about 8. Now, with the biggest bearing on the biscuit cutter up here, there's a groove depth of 10, so that's a bit too much. So I can't use the bearing except as a safety stop. I'll have to use the sled and rotate it around again, and a couple of passes should do it. So I've cut the channel here for the belt. It's going to be interesting to see if MDF is going to be strong enough with a belt whizzing around it, or whether this will simply peel away. Now I've got to cut the middle out so that it will fit over the flange on the wheel, and I'm going to use the circle cutting jig on the plunge router. The other little experiment was to see how masking tape fared as a way of holding both the centre, which will drop out, and the rim, whether it would tangle itself up, but that seems to have worked pretty well. This is of course the so-called luthier's trick, learnt from Crimson Guitars. 2 bits of masking tape, super glue on one, activator on the other. Much better than double-sided tape. I'm just arranging some little wedges underneath those finger and clamp holes in the wheel. You could of course screw the temporary pulley straight onto the wheel, but I'm just avoiding holes in random places in the probably vain attempt to make balancing and truing easier. With the temporary pulley attached to the wheel, I'm now ready to give it a spin and to put a crown on here, and at the same time make sure it's a true crown. A crown that follows the vertical even if the wheel wobbles a bit from side to side. And the reason we want a crown on here is so that the blade will track to the centre of the wheel. On a flat rim the blade would wander off, but magically on a crowned rim the blade will correct itself and always travel back to the high point of the wheel. Now, I have no wood turning skills and I don't trust myself, and I want a gauge. Matthias recommends a 5-degree angle. I'm not absolutely clear what he means by 5 degrees. I assume it's the angle that the tangent to the rim circle would make around about halfway round the rim. So this is 3 centimeters or 30 millimeters, so this distance here is about 7.5 millimeters. And the difference between going around the circular path here or the straight path is negligible. So I'm going to say that this distance here is 7.5 millimeters, and I want this radius here so that I can make myself a correctly curved gauge for my crown. We have a right angle here, we have a right angle here. If that angle is 5 degrees, that's 85, and as you would suspect, that angle there is 5 degrees. 7.5 over the radius in millimeters would be the tangent of 5 degrees. So the radius is 7.5 divided by the tangent of 5. 7.5 divided by the tangent of 5 equals 86 millimeters or 8.6 centimeters. So if I draw myself a circle with that radius, I can cut a piece of wood to act as a gauge with that radius of curvature. I'm starting to realize, I think, why wood turning gouges, etc. are so big and heavy. Putting an ordinary chisel against this, what happens is it follows the profile. It doesn't matter how hard I hold this, instead of changing this to the profile I want, it simply smooths off the profile I've already got. So I think I'm going to have to add some weight to this and increase its inertia so that I'm actually cutting the profile instead of amplifying the profile that's already there. I've decided on a more rigid tool rest and patience. So I've used the bobbin sander to create my guide from the guideline, and getting close now. I think I'll see if I can do a little bit of finishing with some sandpaper in my guide. I've just done a video of the wheel spinning with a bit of red tape on the rim, and I used a fast shutter speed of 1/100th of a second because I want to catch that bit of tape as it goes round. Normally you video at about 1/30th of a second, which gives a smoother result, but I would have just seen a red blur, I suspect, at that speed. But it has enabled me to count the number of revolutions in a second. I had done the calculation. I've got a 1410 RPM 1 horsepower motor. You might think that's an odd figure, but remember this is the UK and we have a different mains frequency, so an induction motor spins at a different speed. It also depends on the number of poles. Anyway, this is a 1410, and I'd calculated that I've got a gear reduction with a 3-inch pulley on the motor of 1 in 4, and I had calculated that that would give me 6 revs per second, and this video shows that that's exactly right. And that will give a fairly modest blade speed. I could go for more power, a faster blade speed, as it is a 1 horsepower motor, by putting a 4-inch motor pulley on. We'll see how it goes when I actually get to cut something. I've got this crowned now, smoothed it off a bit. I'll varnish it in a moment, but one thing I do want to do is place a line on the crown. The sides of the wheel will not necessarily be at right angles to the shaft or axis or axle. But at some point you're going to want to check that the two wheels are aligned correctly. And what you want to be aligned are the two crowns, which should be perpendicular to the shaft. And these lines on the wheels should help me do that. I was mildly surprised that the temporary drive wheel that I made out of MDF lasted. It didn't delaminate, and now the time has come to make the drive wheel proper, and this is going to be out of Baltic birch. And unlike the pulley channel in the temporary one, which was square, this one needs to be a proper one with a 40-degree wedge shape to it, which is the standard profile of a V-belt. Now there's two possibilities. Put that groove into the rim of the drive wheel now and then fit it to the wheel and get it true, or fit it to the wheel, turn the wheel and turn the channel into here. Now my experience with turning the wheels for crowning, I didn't find very pleasant. So I think I'm going to suffer the alignment hassle rather than the wood turning hassle, and I'm going to groove the drive wheel now. If you've got a tilting router table, you could consider using a slot or grooving cutter. I've got my trusty biscuit cutter back in here, and setting it to half a 40, 20 degrees, and then do each side of the groove. I don't have a tilting router table, so I've put together here a 20-degree tilt table, temporary table. Although it's not too temporary, I've got it pretty securely held to the rip fence there. And I've got a pivot to give me the right distance of the rim of the wheel off the table here for this to cut the 13mm, the beginnings of the 13mm top width cut. Now you've got to think very carefully if you're using a grooving cutter at an angle. It's not safe. These are small cutters anyway on that biscuit cutter, and I would have to proceed slowly anyway, and proceeding slowly would be a good thing. You want this to be super secure, this to be super secure. And the other consideration where you really do need experience of using an inclined cutter is what it's going to do to the sides of each cut. Now, as it turns out, it's fine. The side I'm interested in is this 20 degrees side here. And as the cutter has cut this 23, being at an angle, it moves away from that face on its way round. It does dig on its way around into this face. If you were relying on the angle of this lower cut, you'd be disappointed. But we're not. This is waste here. We want that 20-degree angle there, and that's exactly what we get. Then you have to be super careful, because if I was to go straight in and do the same thing on the other side, I would leave a ring-shaped piece of waste potentially. It doesn't look as though I'm going to, but if there were a ring-shaped piece of waste in there on a spinning cutter, it wouldn't be nice. So to do the job carefully, I'm going to now make a flat cut in the center here to remove what will become the waste, and then go on to the opposite cut, another 20-degree cut here. Well, I've cut the centre out of the drive wheel using the circle cutting jig once again, and I've got it now mounted on the wheel. And an advantage of the round flange is that I can check it for concentricity like that. So I gave myself a bit of a gap in case it wasn't concentric, and I made that gap a couple of shims, these useful little plastic packers that I use all the time. And I put a point against here. I've taken it off again now, and it's pretty good. It's within a millimetre of being concentric. Balancing wasn't too bad. My precautions seemed to help a bit, or at least it wasn't a balancing disaster. So I played around with some weights on the rim here, and it's about 15 grams out. I think the law of the lever is linear. If you come halfway in, you're going to halve the force. So I've put some lead in here, about twice that, about 30 grams worth. It was here on the rim, so I've used both of these finger holes for the lead. And I thought I had some roofing lead, flashing, which would have been good because you can cut that and it's malleable. This lead here is somewhat brittle. It must be some kind of alloy, and you don't really want brittle. You don't want to have to saw it because you don't want lead particles everywhere. It's really rather poisonous. But nonetheless, I donned the gloves and the mask and put some paper down and chopped a few bits of lead off. I think it must be typesetting alloy, and I've popped that in there, and that's now close enough.